All right, video number 2. Focus. All right. Now, number 309, this is about solving for the measures of the angles here. So in number 309, I'm looking for the measure of this angle. This is the angle of elevation. It's always in the bottom corner. Even angle of depression goes in the bottom, remember. Depression is made from the top down. Elevation is made from the bottom up, but they're equal to each other. So this is where we're putting it. Okay, I'm looking for this. We have the opposite and the hypotenuse. So once again, that's the SO part. So the sine of x is equal to 4.5 over 11.75. Remember, when you're looking for sine, when you're looking for an angle, you use the inverse, okay? And when you're looking for a side, that's when we cross multiply. So x is going to equal the sine inverse of 4.5 over 11.75. Remember, what we're not showing is the sine inverse of sine, because that's canceling out here. Okay? So, trig, sine inverse, 4.5 over 11.75, and we get 22.5. Nearest degree would be 23. Always go back and look at the question. Okay? All right, 310. Same thing here. What is the measure of angle A? So here, this is adjacent. That's my hypotenuse. That's our cosine. That's ca. So we do cosine of A is equal to adjacent over hypotenuse. And then A is equal to the cosine inverse of 9 over 14. Remember, we're not multiplying. It's kind of like a function where you're plugging in. It's taking the cosine of inverse of it. So cosine inverse, 9 over 14. And we get, and we're going to the nearest degree, so that would be 50 degrees. Okay. 311. Model below, projector into outdoor large screen. The bottom of the 60-foot tall screen is 12 feet off the ground. The projector sits on the ground of a horizontal distance of 75 feet to the screen. Determine its date, theta, nearest degree measure, projection angle. Okay, so there's a couple options here. We do have these two right triangles, the big guy and the small guy. Here's the small one. There's the really big one. Now, in the big one, the height is actually 60 plus 12, which is 72. That's the height of the whole screen. Okay? This has an angle measure here, and we'll call it x. Remember, this is still 75 feet from the screen. So, in the small triangle, right, we have this angle, which we'll call y, and here we have a height of 12 and a distance of 75. If we can just figure out the measure of the two angles, right, this being x and that being y, the difference is theta. And that's it. That's essentially how you have to do to solve that. Now, can we do it a different way? Sure. We can figure out the angle measures and use law of sines, but it's a little bit tougher that way. So that's what we're going to try to do, is figure out using SOHCAHTOA the two angle measures and then just subtract them. So let's take a look at the big triangle first. Okay, big triangle. All right. In the big triangle, we have the opposite side over here. We have the adjacent on the bottom. So we want to do the tangent of x is equal to opposite 72 over adjacent 75. We're going to do the tangent inverse 72 over 75. Trig. Tangent inverse 72 over 75. And I get that lovely angle right there. By the way, Kevin Durant is tearing it up, just so you know. Okay, in the small triangle, we're going to do the tangent of y is equal to, it's once again opposite over adjacent, and then we just do the tangent inverse of 12 over 75. So, tangent inverse, 12 over 75, and we get 9.09027692082. And then remember the answer, theta, is just x minus y. You can write it like this because we've already indicated what x and y are. So if you want to write it with theta being x minus y, that's fine. And then just go do it. And we want nearest tenth, so this is going to be 34.7 degrees. Not done yet, because why? That would be crazy. 312. Diagram below, looking for measure s to the nearest degree. We have the adjacent and the hypotenuse, so that's the cosine. So cosine of s is equal to 60 over 65, and then s is equal to the cosine inverse of that. We're going to bust out the calculator. We're going to do trig, cosine inverse, 60 over 65. Boom, and we get 22.6, which rounds up to 23. 313, handicapped access ramp, say below, every 1 inch of vertical rise and the height must extend out 12 inches horizontally. So, what is the angle of inclination of x to the nearest tenth? Nearest angle of degree. And I want to say I am missing something on this question here. Hold on, I'm going back to the questions above so I can see if I can find it. This should be something, and I can't see it. So let me look this up and I'll get back to you here, because I'm not exactly sure what number should be here. No, this is 1. That makes sense. Because if it's 1 inch high, it's 12 inches across. Using some logic here, people. So this is our opposite. That's our adjacent. We're doing a little tangent action here. And then we're going to do the tangent inverse. Trig. Tangent inverse, 1 over 12. Boom! And we get 4.76. There's choice 1. And we're done. All right. Hope that helps. Let me know if you need anything else. And I will talk to you guys on the flip side. I can't believe I just said that.